In your Laboratory5 folder, the one you can download from Blackboard, you're going to have all these files. And so one of those, it's the folder data, and it's the folder where the training, validation, and testing sets are located. So in this folder data, it's the test, training set, and validation set are different folders. And then on each one of these folders, if I go to the test set, there is a folder for each one of the classes. So if I go to carton, for example, I can see all of the different images for carton or the cardboard class. And if I go to metal, then it's all of the images, the testing images of metal. And now we go to the training set, which is the largest set for each one of these classes, and I'll actually see 400 examples of images of these different glass objects. As you can see, they have different orientation, color, and different object type. So this is where the whole data set is located in the folder data. Now the other objects in your folder, I'm going to explain in a bit. It's the current image. So it's basically an image that is saved when the image from VREP is retrieved. Then that image is saved in this folder by the name current image. And then our convolutional neural network will take this image that's been saved as current image and will classify it. In this folder, you'll also find the installation guide. So it's the guide that will show for each one of the operating systems what is the process to follow to install Python and Anaconda in your computer, and to install Keras and installing TensorFlow on your computer. So as you see, the first thing that you see is the video tutorials for all installations. This for installing all these packages and including the Python API to communicate with VREP. You will have those installations in these videos that are posted in YouTube that you can access for Windows, Ubuntu, and Mac. So there's one video for each operating system. And then this video will show the instructions to perform the installation of Anaconda, Python, Keras, TensorFlow, and the VREP Python API. So the first step is to actually install the necessary packages for deep learning environment in your computer, and there is a video that will show how to do all of these instructions, how to follow them. Then the same for Ubuntu, and then the same for Mac OS. Then after you install this environment you are going to create an environment in Conda that's called TensorFlow CPU to train these networks in CPU. And then after you do all of this installation, then we want you to install the Python API for VREP, which is basically the way that Python communicates with VREP. So you will also see this in the video tutorial. All of the instructions for Mac, VREP, for Mac, Ubuntu, and Windows. And then also this file, you can find the handout of the class in this folder that shows all of the instructions for this laboratory. So we'll explain what the task is about, the waste recycling system, and how to set up the environment, go to the installation guide with all of those instructions, and then once you have installed all of those packages in the Python API, then you'll actually check out the instructions for solving the lab. And so, as I was saying before, we want you to run the online test lab5 folder. So I'll show you how to do that right here in Windows. I'm going to open the Anaconda prompt. Once everything is installed, and once my files for the Python API are here, right? So remote API, VREP, and mirroring consts. Once I have those 3 files in Windows, then I can run this code. First, I need to go to the folder by using CD, and then using CD and then copying the path. I'm currently in that folder, and so now I can run the commands as the handout says. So conda activate TensorFlow CPU. Just copy that command and paste it here. And so now, because the installation is done, as shown in the other video, then in the installation video, then I'm located now in my TensorFlow CPU environment, and I can access all of the deep learning libraries that we installed. So after doing that, we will run the Python online test lab5. So in Windows, I use something called Sublime to change the code. But when you install Anaconda, you also have Spider to read these files, and you can use either one you prefer to change your code. Right now, I'm gonna use I'm going to use this one. So because I'm located here, I'm going to copy all my path and then open it in Sublime, because I actually want to see what this code has. And I'll also open the training network lab 5. So if I open the online test lab 5.py, here in the main function of this file, there are the main instructions that will be executed when this file runs in Python. So if you see this, these 2 lines of code mean that when this code is run as just Python and then running the script, it's going to run the function main. And then the main function will have all these instructions that you saw before in the PowerPoint that I showed you before. And so here, once you train your network, you will have to change it for classifier.h5, which is the name that is saved when you train the network. But currently, it's running the pretrain classifier.h5. That you can also see it's in the folder that we gave you, right? The pretrain classifier h5 is right here, so we can do that. If you have Spider, you can also open the file the same way that I did in Sublime, and it depends on your console. But if you install Anaconda in either Windows or Mac, then you can definitely use Spider to modify your code. But I would suggest to run it from the console prompt. It works the same way. It's the same code. Okay. And so now let's actually run the file. Let's open the vrep scene that we provided for you. And then now that the scene is open, I can actually, and Python API has been installed, I can actually test this network as shown in problem 1. So the way to do that is to actually copy the code. We already did this part, so now let's just copy the code Python online test lab 5 to see whether it actually performs that test. So if you see, after I ran this code, then it showed me it ran vrep, and then it also showed me the architecture of this network, of the network that it loaded. And it will actually wait until the object reaches the console. Sometimes in Windows, if the output doesn't come out and nothing happens, you can click first on this window and then click one of the arrows that will just make it go to the next step. Sometimes it like freezes a little bit, so if you click on one of the arrows, whether it's like training and you see that nothing is happening, it has happened to me in Windows that it doesn't do anything. So if you just click on one of the arrows of your keyboard, it will actually move. So as you saw when I ran this code, it actually waited until the object reached the proximity sensor, and then it picked up the object and classified it in one of the bins. And so it might have been correct or incorrect. You can actually check that for the object. Let's run this simulation again. And so I just pressed Ctrl+C, and then the code stopped. And then I wrote the same command and I pressed Enter. Now it connected to vrep, and it's waiting until an object reaches the proximity sensor. Then as you can see here, it lowered the parameters. It detected that it was metal. As you can see here, class metal, code of metal is number 2. And so it deposited that object on in this bin, on this conveyor belt that throws it in the metal bin. And so you have the names of these boxes, but you also can see here, this is the carton box, glass box, metal, and then plastic. So it's metal, glass, plastic, cardboard. And so what you need to do in this part of the code is actually modify this loop. So if you see the number of times the classifier will run, you can modify it. Let's say I want to run it 2 times. Let's say maybe 5 times. And then you can just stop the code by writing Ctrl+C if it didn't stop before. And stop the simulation. And then I can run the same code again because I saved it. Then I run it again and see if it actually classifies 5 objects or not. And this is the change that you need to make for problem 1. It's just making sure that your setup is correct, that you that you downloaded and installed everything correctly, and that this code actually runs. And as you see, it froze for a little bit, so just click on one of the arrows and it continues the process. And this one was actually an error because that is not the bin of cardboard, that is a juice box. This is plastic and should be classified as plastic, and it did actually correctly classify it as plastic. This is a glass bottle, so it should classify it as glass, and it classified it as carton. So as you can see, it is not a really good network, the one that we have provided for you, but we want you to train to see how it performs for the first part of the laboratory, and then we want you to actually train this network again. So you already saw how to change the first part. Remember, you have to actually do it for 12 objects and then show the results of that in VREP. So now let's look at how to do the second part of the lab, which is actually in the train network lab5 file, in the Python file. So there is a function that is called retrain network. This is a network where you need to make your changes in the train network lab5 file. And so lab5 file. So this you should not change. It's just how to create the datasets from the folders that you saw, the folder data, training, validation, all of that. Then here is where the network is configured, as I showed you before in the class. And then you have the hyperparameters in this function. So here's where you're going to change it. And as you can see, that function is saved as classifier.h5. So this is your network. This is the network that you need to test. So once you train your network again and it's saved with this name, you have to go again to online test lab 5 and change this name because you want to test a new network that you train. And it's going to be named classifier.h5. So make sure you change that, otherwise you're going to be testing the same network that I gave you. So there's also this function called load save model, which loads whatever model it's under this name. So if you input here classifier.h5, then it will load that model or pre-trained classifier.h5. And then there is this other function that's called test train network. And this function is called when you train and also when you're loading the function that I gave you, it will actually test the train network that you input right here. It will test it over the validation and test set. So it will not do the training, but only test how good this network is over these sets. And that is what this section does. Now the predict class file function, what it does is that if you give it a classifier, so the network that you that we trained, and then the name of the image, then it will actually load that image from the folder, from the lab5 folder. Everything happens in the same folder. And it will actually try to predict that image, and it will return the value of that image. So whether it is carton, glass, metal, plastic, and it will return that the number and the name of the class that it detected. So if you see, the main function of this file will be either to load the saved model, which if you run it right now, if you run this script right now, what it will do is it will load the model that I created, then it will test how good it is over the validation and testing sets, and it will just try the current image and try to predict that image. So if I run Python train network lab 5, it will just load the network that already exists. It will output what the architecture of that network is. You can see it right here. And it will also tell you the total number of parameters, how many images are in my dataset. It will give us the validation accuracy, and it should also show the test accuracy. It's just frozen. If I click one of the arrows, it will print test accuracy 0.86. So that's what happens when you run this file. Now, if you want to, instead of save the model, you want to actually train this model, then you can comment this line. In Sublime, you can just press keyboard command to comment, but that basically the way you comment is to add a hashtag right here, and so that line of code will not be executed anymore, and you should uncomment this one because this is the network that This is the function that will retrain the network instead of just loading the network that I created. So you make changes in your network over here. Let's say instead of 16 filters, I don't know, I want 32 filters. So I just save this file and I run retrain network. When I do the same, so I'm just locating my file where my folders are, and I write Python train network, then instead of just loading the network, it will actually create the architecture of this network and will try to train it. So as you can see right now, because TensorFlow and Keras are installed, then it will actually start training the network. And as you see, it will show the progress of one of the epochs. And it will take a little while to finish one of these epochs and train the whole network. But basically, those are all the changes you need to do to train this network again. So after it runs for 100 epochs, then it will stop. It will show you the results and the test and the validation and testing accuracy over these data sets, and you will have already your network trained, and you can just, once it is trained and saved as classifier.h5, then you can just change the value in online test lab and see how good it performs. That's it. That's all you need to do for this lab. And so right now it's going to take a little bit of time to train. Because we are all gonna be training this on CPU, and so once this is trained and it's done, I'm just gonna stop it for a second. You'll actually output all the values that you saw before, which are when you do the test train network, it will output the accuracy of classification, the overall accuracy classification over the testing and validation sets, and you can see that accuracy here: validation accuracy and test accuracy. So after if you do the retrain network, after you retrain the network, it will show you all the accuracy as it is training, and it will also show you the also show you the loss function. And so in order for you to see it right now, let's maybe go back to where it was 16, and let's just choose one epoch. This is not a good number. You should try something between 50, 100, 200. But it's just so you know what happens when it completely it runs. Maybe let's choose 2 so you can actually see what will happen. So let's let it train for a little bit. As you could see, because before I had incremented the filters and it took longer to train each epoch, but if it's less filters, then it will be much faster to train. Sometimes as it is training, it also stops a little bit, at least in Windows, so if you click one of the arrows, it will show you. So this is what it prints once it is done training: validation accuracy, test accuracy. It's really bad, as you can see, because we only trained for 2 epochs. And now after you train, it actually saved your network as classifier.h5. And if you open this image, create an image called training class. When you open that image, it's actually the loss function. So if you have 100 epochs, it will show you all of the loss function of all of your during your training, and you can see that that loss is going down. So this is what this code is doing. And then once that code is done, we go to online test lab. We change this for classifier, and now these results should be very bad because we only trained for 2 epochs, and there's no way that's going to be good results. But you can still run it now that we just changed the name to classifier.h5, and then now it's running. You can see that now it's running with vrep. That should be meta. Let's see if it gets lucky and it detects it. And as you can see, it says it's carton, so it's a really bad network. But after you train, you should have a network that is much better than the one that we provided for you. That's basically all you need to do for the lab.